Machine learning in otherwise into the space of data analytics, we call it as predictive analytics. But machine learning is a combination of predictive and non-predictive analytics. Machine learning has predictive analytics within it and non-predictive analytics also. Okay. This is a very high level agenda that we will be going through. We will get started with the introduction. Then we'll talk about some use cases, some of the essential libraries that we will be using, what are the different types of learning, feature scaling. I hope feature scaling, some techniques you might have already heard about in the EDA classes, but we will again go through. Classification algorithms. Here I will talk about multiple algorithms like naive Bayes classifier, support vector machines, decision tree, random forest, what else? Logistic regression, and many more. KNN and many more. Okay. Similarly, in regression, we will also be learning what is regression and what all libraries do we have. Each and every classifier, the algorithm that we will study under classification, same is also present under regression as a regression. Okay, I will explain that. Then we will talk about clustering. Clustering, these kind of algorithms or these kind of problems are used in clustering. Maybe let's say you have 1,000 customers, you want to create segments out of it or groups out of it. So you will be using clustering algorithms there. Association rule learning or else recommendation system, very important concept. We will also be learning it. Ensemble techniques, hybrid techniques, whatever you want to call, you can call. These are some of the techniques that uses hybrid techniques. Okay, some uh, just imagine A is an algorithm, B is an algorithm. Individually, they are not performing great, but if they combine together, they could be a better algorithm or they could be a more powerful algorithm. Okay, so ensemble techniques is basically hybrid combination of multiple Bayes classifiers or Bayes regressives. Time series analysis, very important concept. I think one of the most important concept in machine learning, I would say, is time series analysis. My first research paper, my first research work was into time series. Okay, so anyways, for all the topics you can ask me, but just wanted to let you know. Dimensionality reduction, also called as feature engineering, will also be covered, and hyperparameter optimization. So probably around 5 to 6 classes will be taken for machine learning, and then there will be classes on real-time use cases or case studies, or in simple terms projects. We will also be solving some end-to-end projects, mostly into time series part and classification part. Regression and clustering are low priority. Regression, literally, it has very less use cases in industries. Clustering, there are use cases, but less. Okay. Recommendation system is also powerful, but we'll be focusing more on classification and time series analysis as part of projects. Okay. So let's talk about introduction first. Many people are confused with these terms. Okay. Machine learning, deep learning, AI, and data science. And it is nothing new. Like, this confusion was present when I started my job as a data scientist in 2015. This problem still exists. Like, just couple of days back, I applied for a job. I got a call back from the HR, and he wanted to talk to me about my profile. I explained him my profile. I told that I'm into data science, and when I say I'm into data science, that already means that I'm good at data analytics also. Like, data science is a umbrella under which data analytics comes into picture. Okay, and AI and all those things also comes inside data science. Okay, but still he understood everything about my profile, and at the end he came to a conclusion that I think your profile is more suitable as a data scientist, but this role I have is mostly into AI. And I was literally laughing. I had to explain him again, so I again went into a call where I had to explain all these things to the recruiter, because sometimes recruiters doesn't know about all these things. And till today's date also, there are many companies who are hiring data scientists, data analysts, or AI engineers, and the one who is hiring, the manager, is not into data science. They are program managers, they are development managers. So sometimes it happens that your manager itself doesn't know about all these things. So we have to explain them, right? So I'll try to explain these four jargons. And next time, whenever you face a problem, when a recruiter is confused, let them understand about this, okay? Because recruiters are not data scientists. They don't know about all these things, right? They just call you based on whatever information they have been passed, okay? So, first of all, I'll talk about AI, okay? So, AI is simply artificial intelligence, okay? So, if I talk about AI, there are multiple fields or multiple areas of research that basically leads to AI. This leads to AI, this leads to AI, this leads to AI, this leads to AI. That means if you perform these things, you are gaining the artificial intelligence. Understood, right? It's a very simple English term. AI means artificial intelligence. That means artificially you are gaining that intelligence. What is natural intelligence? That you inherit from your parents, or probably during your schooling days or college days, whatever you learn from textbooks, whatever you learn from the subject matter experts, that is your natural intelligence, right? Artificial intelligence means you artificially gain those knowledge. What are the different areas of research under AI? Let me just cross check if my recording is going on. Yes. What are the different areas of researches? One of the areas of research is machine learning. One of them is NLP. I'll write it here, okay? Machine learning. One of the areas of research is machine learning. It includes text to speech and speech to text. That means you are telling something and then it is responding back you in speech or other way around. What are some of the examples of speech to text or speech to speech? There are multiple examples, right? Siri and all those things, Google Home, Alexa, all these things are NLP. I will teach you NLP later. Okay. Some other areas of researches are robot process automation, robotics, creation of robots, right? Some other areas of researches are computer vision. Computer vision basically means, uh, let's say somebody thermal scanning. You are walking into some office premises, there is a camera, and that camera is basically capturing your thermal, it is doing thermal scanning and capturing your body's temperature. Or else imagine, these days many cities have implemented this. You don't see traffic policemen standing at traffic signals because there has been camera has been implemented. If you do some mischief, if you don't follow traffic rules, you will get a challan because the cameras are capturing your number plates, analyzing it, understanding it, and then they will find out who the owner is, and then you will get the parchi right at your home. So computer vision. So different fields of researches leads to AI. In simple terms, AI is a superset. Machine learning, NLP, robot process automation, computer vision, text to speech, speech to text, all these things leads to AI. Okay. So ML is a subset of AI. Simple. What do you mean by deep learning? Deep learning is further a subset of ML. Deep learning is not, people say that machine learning and deep learning are different. Deep learning basically comes under machine learning, but it uses some advanced techniques. Okay, it uses neural networks, the way our human brain works. Okay, so if somebody says machine learning and deep learning are different, tell them that machine learning and deep learning are not different. Deep learning is a part of machine learning. Okay, what they mean to say is classical machine learning algorithms are different from deep learning algorithms. Classical machine learning algorithms are nothing but a part of machine learning, CML. Okay, so I'll just rub this off. So CML is a part of machine learning. DL is a part of machine learning. CML and DL are different. What do you mean by CML? Means classical machine learning. That means all these basic algorithms like decision trees, random forests, naive Bayes algorithms, support vector machines. All these are classical machine learning. What is deep learning? Artificial neural network, convolutional neural network, recurrent neural network, auto encoders, transformers. All these are deep learning. Transformers basically is not deep learning, but yeah, some advanced machine learning comes under deep learning. Okay, so deep learning is a subset of machine learning, right? Now what is data science? Data science, as you can see in this particular image, right? Data science is a combination of AI, and it involves mathematics, statistics, EDA, all these things. So in simple terms, the study of data is called as data science. If you come from a computer science background, right, you must have done computer science engineering, right? Like myself, I'm a computer science engineer. So in my bachelor's degree during 2007 till 2011, I studied about computers. Initially, I studied about computers, the different parts of computer. In the second semester or third semester, I studied about programming languages. Then I studied about advanced programming languages. Then I studied about some other, fields which are related to computer science. So in my 4 years journey, majorly I studied about computers. So that's why it is called as computer science and engineering. So when you are studying about data, that is basically data science and engineering. Okay, simple. So if somebody asks you what is the difference between AI and data science, you say that they both are somehow related to each other. In order to perform AI, we have to understand the data, and that is basically data science, right? So at least now you have a lot of things to explain, right? So that is the difference between ML, DL, AI, and data science. Data analytics is again a subset of data science. Okay. If you are a data scientist, then by default, it is understood that you know data analytics. Okay. Because in data analytics also, we deal with data, right? So that comes under data science itself. Okay. Let's take some questions. There is a very good question. Any other questions related to very basic things? Ask me. My SQL workbench is somehow not working. Do I need to delete? Yeah. So I think you have to fix it yourself. In case you have any doubts, ask in the group. Business developer, is it different from business analytics? Business developer, I don't know. This is the first time I'm hearing business developer. That could be some role specific to a particular company. Officially, there is no such role called as business developer. Okay. But yeah, business analytics is definitely a field. Okay. I will explain that in the next slide. Okay. Let me just clear this off. So let's just clarify our doubts. Okay. Business analytics, data analytics, and data science. Okay. Who is a better candidate for which role? I will explain it. Mostly people coming from non-engineering background. Okay. Non-engineering background. They are highly recommended to go for business analytics. Okay. And people who are not at all willing to learn Python. For them, business analytics is the right career path. But in this career path, at certain point of time, you will be stuck. So in order to exponentially grow your salary and grow professionally, you definitely have to migrate to data science at some point of time. Okay. Other than that, difference between BA and DA are very simple. You need Excel for both. You need to know at least one of the BI tools, Power BI or Tableau or Alteryx. But Alteryx is the usage is very low. These days there is also Looker. Again, many companies don't use Looker. Mostly companies use Power BI or Tableau. So either of them is needed. For data analyst, Python is very much needed. For business analyst, Python is not needed. You have to be very good at communications. You have to be very good at presentation skills. You have to be very good at data storytelling. Storytelling. Okay. So Excel, Power BI, Tableau, SQL is also needed for business analytics, and you have to be very good at this. Mostly MBA guys, people from commerce background, non-engineering backgrounds, they basically migrate to business analytics. But data analytics, very similar role to business analytics, but they really don't care about the business. They don't care about stakeholders. They are technical guys. So they will work on tools, Python, data cleaning techniques, data extraction techniques, and so on. Storytelling means you have to be a good seller. For example, in your company, there is an analytics team and they are working on some projects or some EDA use cases or some dashboarding. There has to be someone who will sell this to a client, right? So that person has to be a BA, business analyst. That means he understands what's going on non-technically. He does not understand if somebody asks him what is going on in this dashboard, how did you extract the data, which Python code you used, he might not be able to answer it, but he will be able to sell it. He's a stakeholder manager. Okay, he's good at stakeholder. He's a basically that person who is like a middleman to two different teams. like between a client and actually a development team. Okay, so he's a middleman. Data science, all these skills are required. On top of that, you need machine learning, you need NLP, you need deep learning, computer vision, and multiple other things. But out of these four skills, you have to choose one or two as your primary skill and rest two or three as your secondary skill. That means if after you go through this entire boot camp, maybe you think machine learning is something you can focus on and NLP. So these two will be your primary and these two will be your secondary skill. So accordingly, you have to prepare your resume, right? So this is the thing. And down the line, slowly, once you enter the data science domain, 2 to 3 years experience you have, all of them can be your primary skill. Nothing to worry about. But in the initial phase, yeah, you have to identify what should be your primary skill. And based on that, you have to focus more on those use cases. Okay. If you start touching each and everything, then you will be done. Like you will not be able to, it will be like jack of all and master of none, right? So this is the difference between BA, DA, and DS. Similarly, in DA also, there are multiple other roles. BI analyst. BI analyst is nothing but similar kind of role like data analyst, but they are majorly focused into the BI tools. And others are like secondary skills for them. Excel, SQL, and all those things are secondary skills. Majorly into the BI tools. Okay, understood. Moving on. What would be the day-to-day work of a data scientist role? Depends from experience to experience. But I will also like to explain this thing that maybe I will explain you about myself itself. I did my transition in 2015. Okay, it's been almost 8 years. I'm into this domain. Initially in 2015, I was just working on, I was a data scientist. I was not working on machine learning, NLP, and those things. 2015, nobody knew about those things. So we were majorly working on dashboard building and all those things, right? 2016 is where I got my first machine learning related work. Okay, in British Telecom, I started working on some time series forecasting use cases. Okay, my manager told me about some use cases that we are facing these problems. Can we do some forecasting? So once my manager gave me this use case, I started putting more efforts into the research part. I understood a lot of things within a span of 2 to 3 months. I learned each and every time series algorithm. There are more than 20-30 algorithms that I can tell you right now, which you might not get. Even if you search, you might not get those names. Okay, so there are some arima. Inside Arima, there are multiple flavors like ARMA, ARMA, ARIMA. We have seasonal Arima, Sarima, which is, I call it as Sarima, but it's not the right term. S Arimax, Garch, Facebook Prophet, Neural Prophet, LSTMs, Holtz Winter, Holtz Linear, N bits, at least 20 to 30 algorithms I know, and I have worked on each and everything. Okay, so each and every algorithm is not required because ultimate goal is to solve a use case. So we'll be focusing more on Arima, Facebook Prophet, and LSTMs in this particular course. Okay, each and every algorithm it's not needed, but if you are interested, you can take your work to the next level. After we teach you all these things, you can just go ahead and try out other things also. Okay, so I started working on this and then I built some time series forecasting problems. And once my final Python code was done, my manager told me that we have to create APIs. So I was also involved in creating APIs. That means basically you have to create an API so that somebody can consume it. Just imagine this way, you are creating a web application. Okay, there is a mobile application or a web application, and in this application, okay, I will draw the application here. Okay, just imagine there is a mobile application. Here you are passing all the time series data that for this particular thing, I want a 6 months forecast and all these things, and you have a submit button and you click on submit button. What happens is this call goes to the backend. That means my machine learning code. My backend code is called. My backend basically calls the model, and then model does some calculation. It does some forecasting. Whatever forecasting values it gets, that values are passed to database. Okay, your SQL database or whichever database your company is using, right? and from the database directly you will get the output here. So somebody, the user who is asking for it, will be able to see the forecast. This is how the end-to-end things work. So initial few weeks was building models, and then I started working on the web service call creation, API creation, and all those things. 2017-18, I kept on working in British Telecom on multiple use cases. I worked on time series forecasting, on event correlation, similar to recommendation engines. And this was my day-to-day task. Preparing models for a couple of weeks, showing it to my manager, showing it to the stakeholders, because we have to show it to the manager's manager. Okay. So I was reporting to a manager. My manager was reporting to a line manager. Line manager was reporting to the India head, and we were basically showing it to him, then to him, and then to him. Once he says go ahead, then we build this particular model and finalize the model, and we deliver it so that our clients can use it. Okay, something like that. So this is the day-to-day activity. So sometimes you will also have to uh, work with multiple teams to get data. So that is a day-to-day hustle, getting data, then working on models. Then once model is done, showcase it to the managers or stakeholders. Once you get approval, work on the final models, deliver it. Okay. And again, while you deliver and you work on new projects, you also have to maintain your existing projects, right? So this is how you do it. How you deal with big data during your telecom experience? Big data, our databases were able to handle it, so we were using data lakes and all those things. Some of the statistical models we were deploying it on premises, but some of the models we were also using data lakes architecture. So we were using Azure and AWS and all those things, right? Data warehouses and data lakes. Okay, so theoretically, what is mentioned here? Theoretically, ML is a subset of AI, which we already covered. Name derived from the concept that it deals with construction and study of systems that can learn from data. Okay, so I would like to also explain you one thing about deep learning here. And once I explain this example, you will understand what exactly is a model. Many people gets confused कि क्या है ये model, what is a model, right? So simply think about a 1-year-old baby. I cannot draw a baby. I'm just writing it. There is a baby. Okay, 1-year-old baby. Not 1 year, less than that. Half-year-old baby. Okay, 6 months old baby. Now, what happens is, whenever a baby, 6 months old, okay, whenever a baby spots an animal, I gave this example in multiple videos also. So if you know this, then it's okay. Let's say a baby spots a cat. Okay, what happens? The baby obviously doesn't know about cat, right? So what will happen? Baby's mother and father, they will teach that it's a cat, and they teach using multiple voices, right? It's meow meow, something like that, right? So baby understands that it's a cat. Again, they spot a cat. Again, they explain, oh, this is a cat, this is a cat. And this goes on for 6 months or 12 months, whatever span it is, right? So down the line, for this entire 6 to 12 months, the baby has been trained about thousands and thousands of cats. Sometimes it will be white cat, black cat, red cat, whatever cat it is, different colors of cat, different types of cat. The baby is trying to understand. Obviously, after a span of time, when the baby spots a cat, the baby will be able to recognize that it is a cat. Why? Because thousands of data has been fed to the baby's brain. Similarly, about a dog, right? A dog comes in, mother or father, initially they will start talking that it's a dog, bhav, 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 bhav. And then after 6 months, 12 months, automatically baby will be able to understand. So if a new animal comes in, maybe a cat or a dog, baby will be able to understand whether it's a cat or a dog. And how does it work? Because baby's brain is made up of neural networks. Our human brain is nothing but neural networks. Okay? Neural networks are based out of human brains. The way human brains are trained, similarly, neural networks are also trained. How does deep learning work? We basically feed images to deep learning, right? So if you have a COVID patient data, COVID patient's X-ray, and a non-COVID patient's X-ray, the more images you have, The more images you fed to the model for a new patient, the model will be able to understand whether the patient is having COVID or not, right? And that is how human brains also work, neural networks. Okay. Similarly, machine learning also work. You feed the data to to a machine learning algorithm, to a model. It learns from the previous data, and by learning, it predicts for the unseen data. Okay. Jumping on to the next slide, which is use cases. Okay. Now on the screen, you can see very high level domains, right? There are not even use cases on the screen. Machine learning, deep learning, NLP, there are hundreds and thousands of use cases. Okay. It depends which domain are you looking out for. In telecom, I have worked in telecom, so probably I can talk about 10 to 15 use cases. One of them is call detail record analysis. Call details analysis. You must be watching Crime Patrol, right? In Crime Patrol, if something goes wrong, the police officer goes and asks to get the call detail record, right? CDR records. And then automatically from the CDR records, they do some analysis and then they get to know about all this information, right? Similarly, CDR analysis is also done in the telecom level to understand more about your customers. Okay. After CDR analysis, churn analysis. Churn analysis is a very common use case relevant for each and everything. It is relevant in telecom, in banking, in any kind of industry, in HR industry, any kind of industry. Because customers usually churn, right? Churn means customer leaving a company. Today you are using Airtel. Tomorrow Jio comes with a new plan, 99 rupees unlimited. Obviously, there are certain percentage of people who will switch from Airtel to Jio. So when they are switching, there is a loss to Airtel. So if you are hired as a data scientist in Airtel, you will be able to perform this analysis to understand what's wrong, right? There are multiple time series forecasting examples, customer segmentation, and lot more. Sentiment analysis on customers calling details. Whenever you face any problems, you call to the customer care, right? In banking, also multiple use cases like credit card fault defaults, credit card defaulters, fraud analytics, multiple things. Cybersecurity, multiple things. Phishing, spam or ham, fraud detection. So multiple use cases are there in different industries. In insurance industries, upselling, cross-selling. That means a customer A is having a policy P1 and P3. Customer B is a very similar customer to A. He has P1. So if you can recommend this policy to B, maybe B will take it, right? So these are all use cases in machine learning. So if you are coming from a specific background and if you want to understand what are the use cases in your domain, simply go to Google, try to search healthcare use cases in machine learning. Whichever industry are you from, just simply search these things and do your own research. Okay. There will be tons and tons of blogs talking about various use cases. Okay. Disease detection. Multiple things are there. Machine learning in healthcare. 10 use cases. Automated routine tasks, improved decision making, accelerated innovation. Multiple use cases are there, right? Identifying diseases and diagnosis, drug discovery and manufacturing, medical imaging. Medical imaging is advanced, comes into computer vision, not machine learning, but yeah, you can consider it as machine learning also. As I told you, right? CV, DL, all those things comes inside your machine learning only. But yeah, some people just term it separately, right? Okay, marketing guys have started pinging me. Machine learning based behavioral modification and all those things. Okay, so if you are specifically working into a specific domain, you can do your own research. What are the use cases that we will be covering in the course? Not sure. Maybe I don't know about that. Uh, Maybe we can. Churn analysis is one use case, and probably we'll pick some healthcare related use case. Something. Say in machine learning, there are same use cases are there. Not so funny. I mean, not so uh, great use cases. But in deep learning, yeah, there could be multiple, good use cases in deep learning, especially into the medical imaging part and all those things, right? Let's see. In machine learning, we'll see what all use cases we can teach. These are some of the essential libraries that we will be studying. Yeah, this is just, I don't know why I put this slide, but just it gives you an idea. NumPy is basics. I think everybody knows NumPy, Pandas, Matplotlib, Seaborn, all those things. We will anyways use it. Matplotlib, we'll anyways use it. So apart from that, we will be using SciPy. SciPy mostly will be used for NLP use cases. We will also use NLTK. We will also use some Spark NLP and some other libraries also. Um, sklearn is a very famous machine learning library. Yes, our focus will be sklearn because in machine learning, sklearn plays a vital role. Matplotlib, as I already told you, it's basics. OpenCV will not be a part of machine learning, but yeah, once we jump into deep learning part, we will definitely be having OpenCV. We will have Keras, we will have TensorFlow, we will have PyTorch, but we will be focusing on TensorFlow and Keras. PyTorch I don't teach. Okay. Pandas, Cafe, Theano. Theano is again very old. Minerva, these are deep neural networks. Spider is nothing but a tool, okay, like an ID. So I will be using Spider or Anaconda, Jupyter Notebook. You can use any of them, VS Code or anything that you would like to. Spark NLP is a library. Spark is a different concept used for big data for streaming, but Spark NLP is a it's a new library. Okay, John Snow Labs, created by John Snow Labs. And this is a library, almost 57 to 60% of the healthcare companies are using this library. Okay. So we will be covering that very basics in the NLP part. Now, jumping on to the most important topic of tonight, which will be types of learning. We'll try to wind up today's class a little bit early because basics, and tomorrow we will jump into, not tomorrow, next class we will be jumping into the technicalities, mathematics and all those things. um, so relax today. Okay. Types of learning, majorly machine learning is of three types. Okay. Supervised, unsupervised and reinforcement learning. Okay. There is another type which is called as semi supervised. Semi supervised. Okay. My bad. Semi-supervised simply is nothing but a combination of these two. Okay. That means if you combine, it will become a semi-supervised. I will give an example for that also. Supervised and unsupervised and reinforcement. What are the differences? Do we have a slide? No. So I'll try to cover here. Supervised learning is nothing but a type of learning where you are dealing with labeled data. Okay. Labels. Unsupervised, unlabeled data. Reinforcement is majorly working with a model which has a feedback loop. Okay. Okay. So our deep learning models are considered as reinforcement learning, but there are multiple other concepts related to reinforcement learning. This is a part of, like, this area is basically used in gaming AIs, in gaming industries. Let's say you are playing a game with a chessbot, right? And in 17 steps you are able to defeat it. The next time you play, if you repeat the same steps, you will not be able to defeat it because it auto learns from its mistake. So reinforcement learning is nothing but a type of learning where they have a feedback loop going on. Okay. Talking about supervised and unsupervised. Supervised means labels. That means a type of problem that you know what you are trying to solve. For example, you have a customer's data. Okay. And you know how many of them are active customers, how many of them are churned customers, active, churned, active, and so on. Based on this data, if somebody asks you, hey, these are the 10,000 records, can you use this data and train a model which will be able to predict whether a new customer, let's say the 10,000 first customer comes in, whether the new customer will be churned or active? Can you do that? So here the question is, what needs to be predicted? This particular column for a new transaction, right? So this particular column is called as labels. So this is a labeled data. That means you know what you are working on. Another example is, let's say you have temperature data of a state or a city, Bangalore. So you have date, you have temperature, you have rainfall, and you have other parameters. What you need to forecast? You need to forecast temperature. So what you need to forecast? You already know. That becomes a labeled problem or a supervised problem. So now what is unlabeled? What do we mean by unsupervised? Simply imagine you got 10,000 customers data. Okay. Your manager asks you, hey, you know what? Can you perform some customer segmentation to understand what all customers are similar in nature. Okay, that is the problem statement. So when you have this kind of use case, the first question that you ask in your mind is, how many groups do we create? How many? And do we have a y variable here or a label? No, we don't have. So all these things are not known, right? So this problem basically comes under unsupervised problem, because you don't know what needs to be done. If somebody asks you, hey, these are the 10,000 newspaper or news details, can you categorize them? How many categories? We don't know, right? So that is a unsupervised problem. But if you already know that there are four categories: sports, entertainment, and blah blah blah, and all these things, this falls into sports, this falls into entertainment, this falls into sports. Now based on this, if you want to train a model, and for a new news data that comes in, it will be auto categorized in one of these categories. That basically is a supervised problem. Okay. So so do we get usually unsupervised data? It depends. Like like customer churn analysis, right? Whenever you are working with teams, right, you will be getting access to the entire data, right? And there must be a column, like for example, customer subscription end date, right? Now that, based on that end date, you can create a label, right? That this customer is active or left, and then it becomes a supervised problem. So by default, nobody will be able to any problem. Okay, your call ends in 10 minutes. Okay, so let's try to rejoin the same call. I have issues with my Google Meet. I'll try to fix it over this week. Let us all join back quickly. Same meeting. Same meeting. Join back. Okay. I'm sure. I'm sure कि 10 minute में. Not sure if in 10 minutes this call will be cancelled or not. I don't know. But yeah, just in case the call gets cancelled, I will give you the new link over the chat. Okay, over WhatsApp. So let's get started. Everybody is here. There were 24 students. I think 9 of them were just sleeping. Let me just send a message in the group. Join back. Join back. Okay. So where was I? Yeah. By default, you will not be getting a supervised data set. Nobody will be give you like, okay, take this, and this basically are the list of people, and this is the label. You have to create your labels, right? And some point of time where you don't create or not able to create, that basically comes under your unsupervised problems. You will be able to understand it and recognize the type of problem slowly once you jump into the industry. Okay. So nothing to worry about. Now, I would like to also explain one of the use cases that basically is considered both into supervised and unsupervised. Okay, so let me create a new slide and I will be using that new slide for drawing. Okay, I talked to you about the semi-supervised learning, right? Which is a combination of supervised and unsupervised. Supervised, unsupervised. Any somebody ping me? Anything? Yeah, yeah, we are recording it. I'm recording it on OBS. Don't worry. Okay. So supervised and unsupervised, right? So let me take a small example that is applicable for both. Okay. Let's say you are working into cyber security company, cyber security AI. Okay. Shit, what did I mention? Cyber security. Okay. Now you are working into a cyber security company. Your manager has told you to perform fraud detection. Okay. Now the use case is very simple. I mean, simple as in it is understood that I want to identify frauds, right? So how many classes there will be? There will be one class that is fraud and another class that is not fraud. Simple. That is what the data is, that is what the use case is. Now you get a million records, 1 million records. Okay, your data team has given you 1 million records. Now in the 1 million records, you you everybody joined, right? People are still joining it. Okay, so I will explain you semi supervised right now. Okay, so you are working into cyber security domain, into the AI space. You are a data scientist. You are going to work on fraud detection. Fraud detection means simple that you have to identify frauds, right? So how many classes there will be? Two classes, fraud and not fraud. Simple. Life sorted. But no, life is not sorted. Your manager has given you 1 million records. Not exactly your manager, but he gave you how to get the data. The data team has given you 1 million transactions. Okay. Now, in the 1 million transactions, if you are lucky enough, you will be able to get a column which talks that whether that transaction is a fraud or not fraud, fraud or not fraud, not fraud, not fraud, something like that. If this is the case, it becomes a supervised problem. Life is sorted because you have to just use this data and train a model. Once the model is ready, if a new transaction comes in, then the model will be able to predict whether it is a fraud or a not fraud. Simple. Life sorted, right? Once you identify it as a supervised problem, life is sorted. But the problem arises if there is no such column like this. There is no such column. Okay. Now what will happen? You have 1 million records, but you don't know which one is fraud or which one is not fraud. Now what will you do? Now, okay, from a layman's point of view, what will you do? Anybody answer in the chat box? What will you do here? Just imagine you got 1 million records. Your company has given you 1 million records, transactions. You have to do fraud detection. But how will you start? You don't know which one is a fraud, which one is not fraud. Again, in this scenario, there are two solutions. Okay. Solution one, you ask somebody to label it. Okay. You go to your cyber security expert. You say, Bhaiya, can you do this? And he will say, no, I cannot do this because it's 1 million records. Not possible. So this solution is gone. If he is able to do this, then life sorted, it becomes a supervised problem. Now, if he's not able to do it, what can be another solution? Solution 2 is taking the route of unsupervised technique. You have transactions, but you don't know about which one is fraud and which one is not fraud. So what you will do is you will create some clustering techniques to see how many clusters are we able to get out of this data? Let's say your clustering algorithm gives you some 4 to 5 clusters or 6 to 7 clusters. Clusters simply mean that if there are 500 transactions here, that means these 500 transactions are similar in nature. Okay, it does not mean that it is fraudulent or not fraudulent. It just simply means they are similar in nature. Similar in nature. Okay, let's say this one, 10,000 transactions, similar in nature. Okay, so this is an unsupervised technique where you go and find clusters. But even in unsupervised techniques, you are only able to get clusters. Then what is the next step? Your ultimate goal is to do this, right? So what I will do as a data scientist is, after my clustering is done, then I will go to my cybersecurity expert. Bhaiya, this is my smallest cluster. On the smallest cluster, which is just 10,000 records, can you do the labeling? If he says, no, I cannot do, then go and complain to your manager. Simple. And obviously, he will be able to do it. If he is able to do it, that means out of 1 million records, now you have 10,000 records that have labels. That means you know some of them are fraudulent, some of them are not fraudulent. Now, what you will do is, using this as your base data, using this as your base data, you will go and predict the second smallest cluster. Let's say this cluster is having 12,000 records. So using 10,000 records as a model, you will go and do prediction on 12,000. Again, whatever the model will predict, you go to your cybersecurity expert and ask them, can you validate whether my model is performing good or not? And then he will validate it. And once he validated it, automatically you will understand whether you are going in the right direction or not, and slowly you keep going and keep predicting for rest of the clusters. So this type of problem where you are taking the route of unsupervised learning technique to solve a supervised learning technique is called as semi-supervised. Simply nothing but combination of supervised plus unsupervised. Okay, now many questions, many interviewers ask this, give me an example of both supervised and unsupervised, so you can talk about this theory, right? This is a real-time experience. I solved this problem in 2017 for a cybersecurity company. No, 2019, my bad. No, wait, 2020, sorry, 2020 I solved this for a cybersecurity company. Okay, so this is a real-time scenario I have worked on, and this was my strategy. Understood? So whenever you don't have any idea, then you take the path of unsupervised. What are some of the use cases for unsupervised learning technique? There are multiple use cases for unsupervised. One of them is customer segmentation. Let's say organizing news data if you don't have categories. Um, Understanding the expenditure behavior of customers in an e-commerce platform. So many use cases are there for unsupervised, especially for clustering. So you can go ahead and check it out. Okay, just whatever has been taught today, use this entire week, couple of days for SQL assignment, couple of days for going through multiple use cases, because research plays a vital role in the field of data science. Okay, I will be able to teach you, but I will not be able to spoon feed you, right? So go ahead and do some research. Supervised, what are use cases? Disease detection, churn detection or churn prediction. All these things are spam or ham. All these things are supervised problem. Temperature prediction, forecasting of something. All these things are supervised. Okay. So under supervised, there are two categories. One is classification and one is regression. Regression. What is classification and what is regression? Where you are classifying, that is a classification problem. Like these two are classification problem. Fraud detection, you are classifying between frauds or not frauds. Disease detection, diseased or non-diseased. Breast cancer prediction, breast cancer or non-breast cancer. Churn prediction, churn or not churn. All these are classification problems. Whenever you are doing a prediction on a particular numerical variable, let's say temperature forecasting, today's temperature is 31 degrees, tomorrow is 32, what will be day after tomorrow? Maybe 34. That is a regression problem. You have house price prediction. regression problem. Temperature prediction, regression problem. Okay. And honestly speaking, regression, there are, at least in my 8 years experience, I have never worked on a regression problem, regression industry level problem, because regression concepts are helpful, they are available, but in the industries there is not a single regression use case. Okay. Whenever in a regression problem, if you have a column called as date, right? So date basically means you are converting your regression problem into a time series problem. So time series problems exists, regression problem does not exist. Okay. Classification problems exists. Okay. If you are doing some classification, there will be multiple use cases in classification. Classification and regression are two different concepts. Okay. And in unsupervised, we have clustering and recommendation systems and all those things where you don't know what exactly needs to be done, right? You're not working on labeled data. Okay. Moving on. Any questions so far? Blood sample, is it a part of classification? Using blood samples, if you are doing some disease prediction, or let's say you are identifying or diagnosing people as diabetes or non-diabetes, so if that you are doing, then yes, it is a classification problem, right? So what you need to do to solve that problem is you have to take multiple patients existing blood report data, whatever columns you have, I don't know, like perimeter mean, smoothness mean, glucose level and all those things, and you have to create a label that this patient is a diabetic patient, non-diabetic patient, diabetic patient, non-diabetic patient, and so on. And then using that, you will create your machine learning model, which will be able to understand the pattern. And when a new patient comes in with its own blood report, all these features, you just feed it to the model, and the model will be able to identify it as diabetes or non-diabetes. That is a classification problem. Okay. Let's say you are having patients data. Okay. Let's say blood sugar level, I don't know, or maybe something else, right? For a particular customer, you are kind of capturing the data for the past 6 months, and that you want to forecast for the next 2 days, that becomes a regression problem. Okay. Because when you are forecasting a numerical variable, that is a regression problem. When you are classifying them, that is a classification problem. Okay. Simple. Any questions? Any questions, ask me, we'll clarify, and then we jump into other topics. Okay, then what does regression do? Regression, I told, no, you have to predict the numerical attributes. I'll explain you it. I explained, but I will explain you again. Let's say I'll give some examples here. Okay. Let's say you are capturing Bangalore's temperature data. Okay. The data looks like this. You have date, you have temperature, you have the rainfall, you have what else? Precipitation, you have humidity. All this data you have. Okay. 1st January, the temperature was 31 degrees, rainfall was 0. I don't know the concept of precipitation, but I just know that there is something called as precipitation. So I will just use random numbers. Okay. Humidity, maybe 20%. Okay. 2nd Jan, 31.5 degrees, rainfall 0, precipitation 5, humidity 25%. 3rd Jan, 31 degrees, 0, 6, and 30%. And so on. Let's say you have it till uh, January 2022 till 30 April 2023. Okay, 35 degrees, 0, something, something. Okay, now your manager or your use case is about temperature prediction. Okay, what to predict? You have to predict temperature, right? So you have to predict this particular column. So this particular column needs to be predicted, okay, and others are going to impact, other features are going to be responsible for its prediction, right? Based on other details, you will be predicting them, okay. So this particular column is the column that you want to predict. Obviously, if you want to predict it for the next 5 days, maybe for May 1st till May 5, obviously the values are going to be numbers, right? The forecasted values. So this is a regression problem. You want to forecast temperature, okay. Let's say same type of example, your use case is simply whether there will be rain or no rain, okay. So you have another column, rain or no rain. So in the first day, was there rain? No. Second day, was there rain? No. As rainfall was 0. No. Let's say no, yes, yes, no, yes, no. Now, if you want to identify whether there was rain or no rain, you want to predict it for the next couple of days, whether there will be rain or no rain, that will be a classification problem. You are classifying a particular entry as a rain or no rain. But when you are predicting on a numerical attribute, that becomes a regression problem. Understood? Okay. So based on the data that you have to change little bit. Okay. Sometimes you might not be able to have this. You have to create it. Okay. Based on some threshold. Now another important concept in the field of machine learning is same. I will take another example, maybe customer data. Okay. So you have customer ID, you have customer age, you have customer location, you have customer bandwidth, you have customer something something something, and there is a column called as exit which tells this customer is active or not active, okay. All these information are there, right? Now your use case here is, the use case here is to identify a customer is going to be churned or not, churned or not, right? Which means I want to classify them as either churned or not churned, right? What to predict? This to predict. I have to predict this. So this column I have to predict. So this column is called as y variable. The column that you are going to predict becomes your y variable. Okay. It is also called as dependent variable. Why? Why? Because this variable depends on this, on this, on this, on this, on this, on this, on this. In rain prediction, it depends what you are trying to solve. If you are trying to solve whether there will be rain or no rain, that becomes a classification problem. Whether if you want to do a forecasting on the temperature or rainfall, what will be the numerical rainfall value or the temperature value, then it becomes a regression problem. There is nothing called as first to do classification and then do regression, right? Both these problems are different. It depends what you are trying to solve. Okay. Coming back to this example, this exit is a dependent variable or also called as y variable, right? Dependent because it is dependent on all these features. So what are all these arrow marks called? They are called as x variable, otherwise called as features, otherwise called as independent variable. Okay. You can remember is this way, that your ex, everybody might be having your ex, maybe ex-boyfriend, ex-girlfriend, and they have left you, right? Or you have left them. That means you are independent, they are also independent, right? So x means independent, y means dependent. Okay. You can remember in this way. Okay. So what we need to predict, we need to always predict y. Based on what? Based on my x. All the x features or x variables are impacting this particular thing, which is y. Okay. So y is dependent variable and x is independent. Understood about dependent and independent. Now, another thing I want to explain here is, let me erase some of them. Okay. Another concept I want to explain is train and test. What do you mean by train and test? So in machine learning, what happens is we mostly divide the data into two chunks. One is training and one is testing. Okay. So simply imagine this thing that you have 10,000 records, right? And you want to create a machine learning model. Now, if you train the entire data to the machine learning model, how will you test it, right? So it is not advisable to use the entire data for your machine learning model building purpose. What is the solution here? Simply divide the data into whatever ratio you want. Uh, there is no such thumb rule, but people usually go for 80-20 or 70-30 or 75-25. You can go with either one of them. Okay, no thumb rule. What does this mean? That means 8,000 data will be my training data and 2,000 data will be my testing data. Now what will happen? I will create my model using this 8,000 data, and on this 2,000 data I will do the prediction. Okay, simply what does it mean? Simply it means this. Imagine you have 10,000 records here. Okay, so this blue chunk is my testing data. So, and the upper chunk is my training data. Okay, so what I will do is I will create my machine learning model on my training data. Okay, so I will pass my training x data and my training y data. That means this data and this data I will feed, and I will create my model. Once my model is ready, I will test it on my testing data. But while testing, I will not pass this data. I will only pass my x data, testing x data. Okay, once again. So I will only pass my testing x data. What does this mean? This means I will only pass this x variables and call this model, and the model will be able to predict. Let's say in simple terms, I only have 4 records here. Okay, so the model will predict. For first customer, the model predicted as churned, not churned, churned, not churned. These are my predictions. How will I get to know whether the model has done a good job or not? What I will do is I will, as my model has already predicted, I will now compare it with the actual values. Okay, what are my actual values? My actual values are n, y, and n. So this is my actual data, this is my predicted data. How will I compare? First with first. Is it a correct prediction? No. Second with second, correct prediction? Yes. Correct prediction? Yes. Correct prediction? Yes. So how many correct predictions? 3 correct predictions. How many total predictions? 4. So what will be my accuracy? 75%. I just took an example with 4 records. Okay, literally we will be having hundreds and thousands of records, so accordingly we will get our accuracy. Okay, right now I'm not confusing with other jargons. There are many other jargons like recall, precision, and lot more things that I will teach you later. Okay, right now just be happy with accuracy. But there are a lot of issues with accuracy also. Usually we don't go with accuracy. There are multiple other metrics to validate whether our model is performing good or not. But right now, just consider accuracy as the best thing. But later on, I will explain. Able to understand or any doubt? If you are clear, let me know in the chat box, clear or okay or anything, and then we'll move. Yeah, right. Simple, right? Everything is going simple, right? Yeah, things will become more and more complex slowly, slowly, but yeah. Okay, last concept before today's call is winded up, and the rest technicalities we will jump into the next class. Okay, so feature scaling is a very important concept that is used in the machine learning process. Okay, feature scaling, I believe I have already taught you in the EDA class, but in EDA we have not used it, right? In machine learning we will use it. Now somebody tell me, I will not show you, I think I have already shown how many feature scaling techniques are available. What are the two major feature scaling techniques? I have taught this in ADA, 100% sure. I have myself taught, I remember. Don't Google, okay? What are the two major feature scaling concepts? Come on. Okay. Remember about standardization and normalization. Okay. Standardization and normalization are the two most important concepts in feature scaling. Okay. Now, what each one of them does is very simple, but before that, we'll try to understand why do we need feature scaling in machine learning. Okay. Anybody remembers the formula? X dash is equals to x minus mu by sigma. Remember or not? Yes or no? Just tell me. And this is equals to, remember? Not Ritu, it was taught. Okay, no issues. How do we transform? I think I'll give a small example and then I will show you why feature scaling is important. Okay, just imagine I have 10 numbers. Okay, 5, 15, 15, 15, 18, 20, 22, 16, 6 numbers. Okay, now what will be the mu value here and what will be the standard deviation value? Can somebody tell me? You can use Google, it's okay. I will also use Google. Standard deviation calculator, because I don't have time to mathematically prove it right now. 15, 15, because these things are already taught. Okay, so standard deviation mean is 17.6 and standard deviation is how much? 2.6. Okay, okay. So what will be my x dash? It will be 15 minus 17.6, which is minus 2.6 divided by 2.6, which is minus 1. Again, this will be minus 1. 18 minus 17.4 divided by 2.6, which is 0.15. Okay, and so on. So these are all your scaled values based on standardization. Same if you want to do for normalization. Let's say x is 15, 15, 18, 20, 22, and 16. What will be x dash? X minus x mean. What is mean? Mean is 15. So this will be 0, 0. 18 minus 15, 3 divided by 22 minus 15, which is 7. 3 by 7, around 0.4, right? 20 minus 15, 5 divided by 7, around 0.7. This will be 1. This will be again 22 minus 16, 6 divided by 7, almost 0.7, 58 is 0.8, 0.85, something like that, right? So this is your normalized data. This is your standardized data. This is your normalized data. Okay, and you can see that the values are scaled down. Okay, the values are scaled down. But why do we need standardization and normalization? That is the most important thing, right? So we will try to understand that. So I will just erase it, everything. So normally what happens is the reason why we need to scale down is because of computers. Okay. Computers are not human beings, right? So computers don't understand, like they just understand numbers. If I tell you I am capturing height and weight, same story, I have already covered it, but yes, just covering it again. Let's say I am capturing some people's height 175, 170, 182, 165, 172. Okay. Now, can somebody tell me what is the units here? Is it in centimeters? Is it in meters? Is it in inches? Or is it in any other metrics? It is in centimeters. Why? Because human brains, right? Since birth, we know all these things. We all know all these things, right? So it is understood that we know it is in centimeters. If I talk about weight, 70, 75, 82, 75, 71, we know it is in kgs. It cannot be in grams. It cannot be in lbs. It is not possible for a human being to have 175 height and 70 lbs, right? 70 lbs is almost like half, like 35 to 40 kgs. Not possible, right? So it is in kgs, but that our human brain knows. Computers does not know. Whenever we pass this data to computers, computers need to have a standardized data or normalized data. In simple terms, they want scale data. If you don't pass, then the numbers will be like it will be treated as biased numbers. Computers will most probably give this column more priority than this because it is a larger number rather than this, right? So it is not good practice to pass numbers like this. There could be a column like salary. It could be like 10,000, 12,000, 20,000, right? If you directly pass these values with these values, your model will be simply messed up. Your computers don't understand these things, right? The most accepted format in computers are byte, zeros and ones. So it is always better to scale it down. If you scale it down, then the feature importance remains the same, and the model, the algorithm, the computers, they treat the data as unbiased data. Okay. So if I take this simple example, as normalization is easy, so I will create the normalized data. Okay, so I'm doing h dash, which is my normalized height, and weight dash. Okay, so what is the lowest value? 170. Sorry, not 170, 165, and the highest is 182. Here the highest is 82 and the lowest is 70. Okay, so what will be the normalized value for the first record? 175 minus 165, which is 10, divided by 182 minus 165, which is 15, 17. Okay, which is 0.58. For the second record, 5 divided by 17, 0.29. For the third record, it will be 1. Okay, for the last record, it will be 0. And for this record, around 7 divided by 17. 7 divided by 17 is around 0.4. Same I will do it for weight. 70 minus 70, it will be 0. 75 minus 75, 5 divided by 8 is around 0.6. 5 by 8 is around 0.6. This will be 1. 75 will be 0.6. 71 will be around 71 minus 1, 1 divided by 8, around zero point 0.1. Okay. Now, so understand this thing. In the original data, which was highest? This was highest. And this was lowest. In the transformed data, this is highest and this is lowest. So the feature importance are remaining the same. In the weight data, this was highest and this was lowest. Here also this is highest and this is lowest. So feature importances are remaining the same, right? So there is no harm in using this data. And both these data are in a similar scale. Both of them are in the range of 0 to 1, most accepted format. So that is one of the reasons why we perform feature scaling. Okay. Now, the most important question in interviews, they ask this: which one is a better technique? Okay. So, in machine learning, there is a generic answer. You can tell them. Nobody can tell you which is the best technique. It is always hit and trial. Okay. And then if he's genius, he will ask you, how will you hit and trial? Okay. Then what you can do is, sir, I will take the data, I will perform standardization, and then after performing standardization, I will be creating models, testing it on my testing data, and check my accuracy or whatever metrics. Same I will do it using normalization, model creation, testing data, and then accuracy, and I will compare these two. And then only I can say which one is good, which one is not good. There is no other way. Okay. So this is a generic answer, right? But it only works on some people. Some people, they will they will not be convinced with this answer, right? So what you need to tell for those people, if they are not convinced, then what you need to tell is, firstly, we have to check whether the data is standardized data or not. What do you mean by standardized data? That means if they are following the standardization curve or not, normal standardization curve or not, right? If they are following this curve, then standardization is preferred. If the data is skewed or right skewed or something like that, then it is better to go with normalization. And after this, you do a follow up on this thing. You tell them that this process is very tedious process. So either we do this or arbitrarily we can choose one of these techniques and go ahead, because both of these techniques are very similar to each other and it does not gives a huge impact. As in, you cannot simply say that standardization is like this much times more effective than normalization. Nobody can tell that. They both are very marginally different from each other. So unnecessarily, we don't usually waste a lot of time in identifying which is good and which is not. So arbitrarily we take one of these and then build our model. Okay, that is the answer that you need to give. You need to focus more on the hyperparameter optimization part. You can tell, sir, if we give more time into hyperparameter optimization, we can improvise the models there. So in this process, arbitrarily we can use any of them. Understood? So that's all about feature scaling. Let's just go through the theoretics. Yeah, this is just an example. Most machine learning uses Euclidean distance, hence without feature scaling, most of the algorithms neglect the units and focus on magnitude. In that case, the Euclidean distance may vary significantly, hence output will be impacted. What is Euclidean distance? I will cover that in the next session in the regression part. So there is standardization, there is mean normalization, min max, vector scaling, and lot more things. So usually it is not recommended to waste a lot of time in choosing your feature scaling technique. You can randomly go with any one of them. Okay, that is the Guru Mantra. That's all about today's session. We can wind up the call here, but before that, we'll take 5 to 10 minutes inputs from you guys. In case you have any questions, anything, let me know. Regression will be our next topic. I think regression I will teach you later. Next class we will jump into classification. It's more important. Regression concepts are fine, but yeah, we'll have low priority on regression. Okay, classification, recommendation system, and this thing time series will be more. Questions? Any questions? I'll be leaving this PPT as well as part of today's deliverable. You can go through the PPT and so will we practice side by side any case while learning? Yeah, we will. So for classification, once we teach that, we will show you some projects and then you can pick your own project and start working on it. Yeah, I'll do it right now. My classes, I think I upload the videos very quickly. But yeah, Sangamesh, he gives a little bit late, so he uses Zoom, right? So it takes a little bit time for processing. Then he sends us, we see the message next day morning, then we upload, something goes wrong. So yeah. Thank you, Sumit. Which ML models we'll be using for predictions? We'll be using most of them. I will, in the meanwhile, I will also tell you which one is good, which one is not good, which algorithms to focus on, all these things I will tell you. Like today, I told you, right? Our major focus should be on classification and time series. Second priority will be recommendation system, otherwise known as association rule learning. Lowest priority will be regression. Similarly, when we jump into classification, I will tell you which algorithms are most important and which algorithms are least important so that you can focus more on them. Okay, guys, thank you all for joining in. See you next Saturday. And please do not forget to go through the SQL assignments. It is mandatory. And yeah, that's all about the session. Thank you. Bye bye. Have a good week ahead.